technologies he's sort of using, that he's matched with, right? So he went from this small piece of real estate to something that's much more sophisticated than that small piece of real estate, and that's in fact his success, his economic success, wouldn't have been sort of imaginable if he hadn't at some point switched from one technology to the other, right? My guess is if he had stayed on the street corner, he would not have vacationed in the space station, right? Now, of course, the fact that he switched technology is an endogenous thing. It's because it turned out he was very good at what he was doing. He wasn't quite sure about that on the street corner, but over time, he revealed his type in some ways, okay? So we're going to think of this story just to motivate what we're doing. But I want to be clear, this is not a paper about, you know, Steve Jobs and Guy Laliberté. In the model, there are people that are going the other way, right? So there are people that start successful early on and then disappear into obscurity. People who are kind of just bumbling along. So everything happens in the model. The Guy Lalibertés are also in the model, right? But you can move in any direction over your lifetime in this model, and we're trying to see first of all, what does the data tell us about career paths of managers and entrepreneurs in general, both over the life cycle, but we're also going to look what some of the cross-sectional patterns are in the data. Okay? And then we're going to use that to set up a model that can speak to those facts. And I'm going to focus on the theory today, and I'm going to give you a little bit of a preview of what the empirics work. We're not quite where we want to be in terms of the empirics, but we're slowly getting there. Okay. So, like I said, we're going to look at some data, and the data that we're going to use is a data set that a lot of people have used in this literature, which is a matched employer-employee data set that covers the entire Danish labor force, and we have a 10-year window of that. Okay. We're not going to look at everyone in the data set. We're going to look at individuals that we can identify as either being CEOs of a firm or potentially are entrepreneurs in the sense that they may not formally have the title of a CEO, but they run a family business or self-employed potentially. Although I'll tell you a little bit about who we're going to drop from the sample. Okay. So we're going to look at in the data kind of what in the entire data set, what do these trajectories look like, right? Who becomes a manager and when in life do they become managers? Okay. Once they are, what happens to them? Do they move around? Do they move up? Do they move down in terms of the size distribution of firms? Do they enter or exit? All of these things are happening. And then we're also going to look at what the cross-sectional distribution looks like. So what's the age distribution of all these managers in the economy, right? Potentially we can slice this in different ways. We can look at the age distribution by firm size, or we can look at the size distribution of firms by age. So we can slice it any which way we want. And we're going to sort of zoom in on a few relevant margins.
But the data doesn't tell you who wanted to become a CEO.
No, so the data doesn't tell us that, right? So maybe you want to be a CEO really badly, but you just never had an opportunity. We're not going to be able to distinguish that, right? So from our point of view, is you really want to be it, you just don't have what it takes to be, right? That's kind of the revealed preference argument that the data says, like, if you really were born to be a CEO, you would show up as a CEO sooner or later in our data set. I mean, it's a leap of faith, but that's how we're going to deal with that, right? And then we're going to think, so once we've established that, we're going to think about what kind of model can sort of speak to those kinds of facts, right? What do we need? What are the ingredients that we need to do that? So that'll be what I'm going to focus on for the most part today. And then we can, as a next step, and this is very preliminary at this point. In fact, I'm not going to talk about this particular thing at all, but going forward, we want to think about this, use the model to speak to whether or not the mismatch of managers, essentially frictions along the selection margin into entrepreneurship and managerial occupations, whether or not there's something about aggregates that we care about in terms of measure TFP and so on and so forth. Right? I've done some earlier work on that sort of would connect the two papers. I'll skip this. Yeah.
You also link the CEO information to some extent to the
So we're going to use, so we know a few things about the firms that they work for, right? So we know employment, we know value added. For the most part, we have some measure of capital stock. It's book value, but it is what it is. And we have, in most cases, we have some measure of either sales or profits. Okay, so we're not going to use that information all that much other than to rank firms by size. So we're going to say whatever generates these kinds of outcomes is driven by some fundamental productivity difference across firms. But we're not going to think about the firm dynamics very seriously here. In fact, on the firm side, things are going to be fairly static. Okay. So what are the kind of the stylized facts that we're trying to understand here? So we have 10 years worth of data from 2000 to 2009, and when we sort of pick out the individuals in the data set that fit our criteria, right, that we would call CEOs or entrepreneurs, a few patterns emerge that we're going to try to replicate in the model. Right? The first one is that young workers are very unlikely to be entrepreneurs or managers. Right? So by young, I mean we're looking at the sample from age 25 to 55, okay? And we're looking at it in sort of 5-year increments, just to slice the data in some particular way. So the young workers, age 25 to 29, there's very few that would show up as being either an entrepreneur or a manager. And then there's a large inflow of individuals that decide to take on these occupations. And so the age distribution is heavily skewed towards older guys. Okay? And I'll show you some pictures later on. Okay? Turns out that if we look at individual spells, meaning for us that's a match between an individual and a firm, those are relatively short for young managers compared to older ones. Right? So compared to your young dynamic entrepreneurs, older guys are fairly sedentary. They tend to stick around for a long time. To the extent that we see movement, a lot of that is movement into retirement. Potentially it looks like even early retirement. But the spells themselves are fairly long. And then we also have some pretty stark patterns in terms of the age distribution by firm size, by firm decile, if you will. Right? So it turns out that for young, I mean, there are not very many young entrepreneurs and managers in the data set, but conditional on being a young entrepreneur, they're heavily concentrated in very small firms. Right? Very few run firms that are in sort of the top deciles. Okay? And that the sort of a profile, if you think of here, is the young to old, and kind of like a histogram. For young entrepreneurs, it kind of looks like this. It's tilted towards small firms, and then over time, it kind of tilts over the other way, right? Where older CEOs tend to be more evenly distributed across the size distribution, with a, sort of a little bit of an overhang towards larger firms, right?
Can you distinguish here small firms from young firms? Or?
We can, although we're not using that here. But with something that we could do. We haven't done that yet. Yeah.
You know, if they are family-owned firms as opposed to public traded, because the way you get to be manager in a family-owned can be quite different from the way you get the manager.
Yeah. So we cannot tell for sure, but we have, I think, pretty good ways to get at this, right? So because we have, in fact, not in this particular data set, but in a separate data set, we actually, so all these firms, the vast majority of these firms, are stock companies. That's sort of the predominant form, but privately held, many of them, right? So you can be a family firm and legally be registered as a stock company. But it does come with disclosure requirements, right? And we can use that fact because then we can check who's sitting on the board. And so then oftentimes you see that it's the same family name, right, on the board. And in fact, oftentimes the CEO and the board of directors is kind of, you know, probably husband and wife or something like that. You see a lot of these like small firms that are organized as stock companies. But we try to sort of see who is a family firm and who is not. We can't do this like foolproof, but I think we're pretty good at doing that. And in fact, sometimes we slice the data with the family firms in there. Sometimes we leave them out, just depending on what we want to do. But we can speak to that.
The Sonic law wouldn't work, though, right?
Pardon me?
The son-in-law would work.
The mother-in-law is the effect, right? No? This is a different paper where, well, let's not get into mother-in-laws. And then the fourth fact that's relevant for us is there's a lot of churning going on, so there's a lot of entry, a lot of exit, right? What we also want to understand is how these managers, CEOs move from one firm to another, right? And there the patterns are also pretty strong in the sense that they're inverted U-shaped, meaning very early in your career there's a lot of entry and exit. You try once or twice, you go in, you try it for a year or two, and then you exit. Turns out you're not very good, so you're gone, okay? Very late in life, you're pretty sedentary, right? So you've become a CEO, and if you leave at all, you're going to retirement. Okay, it's in the middle, kind of in your late 30s, early 40s, that you tend to hop around the most, right? You go from a small firm to a big firm, or from a big firm to a small firm, and it turns out that firm performance is a pretty good predictor of which way you're moving. So if your firm does poorly, if you switch at all, you tend to switch down to a smaller firm, and our interpretation is like you're probably not very good at what you're doing. Vice versa, when the firm is doing well, you tend to switch up to a larger firm. And that is heavily concentrated in the middle of the age distribution.
Do you have a sense if most CEOs in Denmark are Danish?
This is a wild guess, but I think the answer is yes. Yeah. 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 Okay. So how we're going to take these kinds of stylized facts and how we're going to sort of set up a model that can actually speak to those. And in its simplest, what we're going to do is we're setting up a standard assignment model with a couple of twists, if you will. One is that there is going to be an overlapping generation of workers that then select into being managers or not. The other thing that happens is that there's learning about types going on, right? So the way you want to think about this is, I'm in front of you here, and we're not yet sure how good this paper is, right? But I'm kind of equally confused about that as you are, okay? By the end, we'll have learned something about this paper, right? And that's the sense in which you update here. There's no private information, it's just everyone learns about someone's true type over time, and that's going to be what's key for the endogenous separation and match formation, including entry and exit that we set up. We're going to allow for the formation of a new match to be costly, right? We're setting it up as a deadweight cost. That doesn't have to be that way, but that's how we're doing it. And the way it works is you form a match, right? Based on the information that you have, new information is revealed each period, and ex post each period you might decide that the match actually isn't very good anymore, and you decide to separate and find a new pair for both the firm and the manager. And for the manager, it might mean leaving the assignment market altogether and become just a regular worker. Okay. So in a sense, so these three things are what are going to generate results that are slightly different from what you have in just like a single cohort assignment model. Okay. So let me set up the model in detail here. So there's going to be a unit measure of individuals, and they draw abilities, these are managerial abilities, from some known distribution, right? So everything is normally distributed here. It has mean zero, and it has precision phi, okay? Now what you don't know is what your true type is, so you don't get to see alpha, okay? What you do see is something that I call A, which is your true type plus some noise that is IID over time, and you get to see it every period. Okay? So then what you're going to do is everyone, including yourself, you're going to look at the sequence of these A's, because you draw a noisy signal every period, and you're going to update your belief about your true type. Okay? Now the reason we have overlapping generations here is because if everyone were to live an infinite number of periods, then you would eventually know who you are for sure, right? But the overlapping generations is going to make sure that no one ever actually knows for sure. Those with like the highest precision eventually are going to exit, and new guys with sort of low precision beliefs are going to enter. And so there's going to be a stationary distribution of beliefs that's never going to collapse to the true distribution of types. So there's a unit measure of individuals in total, they're going to live for a finite number of periods. So retirement here is exogenous. And any cohort that exits is replaced by a cohort of the same size. So the size is going to be 1 over R, right? So that adds up to the unit measure. And then we're going to assume that on the firm side, there is going to be a measure N of productivities or technologies that are distributed according to a distribution G with positive support. And we're going to assume that the firm side of the market is the short side. So there are fewer firms than there are individuals.
With respect to the data, are you guys going to do some above Kramer's Marvel's type of estimation, get fixed effects of these CEOs and kind of map that to alpha, or are you going to be agnostic about how these earnings evolve over the life cycle of these CEOs and the data?
So we're not going to do the AKM at all. Okay, what we're going to do is, so we're just essentially going to use the structural model to tell us what the parameters are, and that will tell us, it will map, not in the planning problem that I'm showing you here, but in the decentralization that will translate into earnings, right, period by period. So everyone in this environment is risk neutral, the individuals as well as whoever owns the project, which doesn't really matter here because we're talking about the planner's problem. And then the match surplus is a function x that depends on the project that you're matched with, right, and your contemporaneous contribution, right. So this is A, right. So that the observed surplus of a match is what allows you to make the inference about your contribution, which is what drives the Kalman filtering of types over time. We're not going to put too much structure on X other than to say that it's supermodular, right? So it's kind of what's required for the standard sorting result in this literature. Okay. And then we're going to allow for the fact that every time you form a new match, you may have to incur a cost, the deadweight cost, mu. We're going to look at both cases. The case where this cost is 0, because that's a particularly sort of clean and simple way to solve the model. And then we're going to look at the quite a bit more challenging case where these match formations are costly. Okay. So how does the matching actually work here? So think of this as the planner's problem. So how does the planner decide to allocate individuals to productivities? Well, the planner has the same information everyone else has, is that it just has, he has to rely on the beliefs about everyone's type and knows the individual's age. And based on age and belief, individuals will be assigned to these productivities that are where within a cohort, you're going to sort perfectly, right? So high ability individuals are going to be matched to higher productivity firms and all the way down. But of course, the additional challenge here is you have multiple cohorts that are populating the economy at the same time. So you have to make sure that if David and I are both matched to the same firm, well, the planner has to be exactly indifferent between David and I being at the same firm. David's probably younger than I am, right? So that's going to matter. But for this to be optimal, it has to be the case that in expectation we produce the same value or surplus, right? So that has to sort of be true across cohorts as well. Over time, these beliefs are going to change, right? So we have some distribution of beliefs today. We're going to form a match, and then everyone gets a new signal, and we have to update everything. How do we update? Well, you had a belief yesterday, and then you get a new observation today. And you're going to update using these weights that depend on age, right? So how does this work? It's a little bit easier to see here. R is the age. So as you get older, you're going to put less and less weight on the signal and more weight on your prior, right? So your beliefs are going to start to sort of converge to something that doesn't move around very much. The variance of that belief, right, doesn't depend on the realization of the actual signal. It's just deterministically the variance is going to shrink over time. So older workers are going to have much more precise beliefs than younger workers, right? And that's going to matter because this potentially interacts with the curvature that we have on the surplus function, right, on x. What's key for us here is to keep things simple is that the update, right, so the update about your beliefs does not depend on the match that you're in, right? So there's no sense in which matching gives you better signals in any way, including when you're unmatched, right? So you get a draw even when you're not matched. That just avoids any sort of strategic motives for becoming an entrepreneur at any point in time. So, and that's mostly for simplicity, but I don't think it's an unreasonable assumption.
SIMEON?
Yeah.
So I'm just not familiar with these models. So there's a rule, there's a theorem or something that says the market and planner are going to have the same outcome?
No, I haven't said anything about the decentralization.
Later you're going to do a decentralization.
Not here, but there is a decentralization, right? But I'm just, to build it, it's a little easier to just walk through the planner's problem to understand how it would allocate, and then there is a decentralization that will implement the optimal allocation. Right.
I guess what I'm saying is, so we think that what you observe in Denmark is well represented by the solution to the planner's problem.
Yeah, we think so. So, I mean,
And the reason is?
the reason, our take on this is labor markets are actually fairly flexible in Denmark, right? So it's not, I mean, I came into this project with the prior, these must be sort of very heavily regulated. It's like this, you know, I don't know, the Scandinavian model, I didn't really know what that meant, but it turns out that labor markets are very liquid in Denmark. So I think it's a reasonable approximation. Okay, wait. Okay. So then,
So I have a question about previous slide. So do you have to assume that this epsilon variance is constant over that cycle? If you assume they depend on the age, then you have a pretty flexible way to model how this belief drift over that cycle, and the calibration would be easier.
yeah. So here we're using that the signal is always the same, is drawn from the same distribution. You don't have to do it that way, right? But here we do. It just keeps it a bit simpler, right? But you could assume that maybe the precision of epsilon changes with age, okay? I think it wouldn't, well, of course it would matter, right? But I don't think it's crucial for what we're doing here. I think having the same distribution.
The calibration is going to match the life cycle of the norm, and this can help you to match the norm.
Yeah, it could. We haven't actually thought about that. But yeah, it's potentially something to think about, yeah. But to be clear, here we're just assuming that the signal is drawn from the same distribution each period. So it doesn't depend on age. Okay, so once you have a match, right, so we know what the technology is. You're producing output based on the realization of your ability today, right, which is your true type plus some noise and the match. And then you just have to know what the distribution around that is. And it actually is very easy to characterize here. We know that this A here is going to be centered around your belief, right, A hat. And it has a variance that only depends on your age. Okay, again, so older workers are going to have higher precision, right? So lower variance compared to younger workers. And that's going to matter here because we have curvature in X. So if you and I are both, like, say, a type 17, given that David is younger, right, we're not going to produce the same amount of surplus in any particular period, even if we're matched to the same productivity. Okay. And then sometimes it helps to just be able to keep track of the cohorts. So we know that the beliefs in each cohort have to be, of course, centered around 0, right? I mean, that has to be the case. Otherwise, you could improve upon that. And then as you get older, you'll see that as R goes to infinity, this will actually just collapse to 1 over phi. But we're never going to get there because R is capped at the retirement age, cap R. So the planner's problem can be written down as the Bellman equation, where the state is the joint distribution, which is called, it's actually a density, H, of all the matches, so that's over Q and A hat, okay, plus all your singles, meaning all the workers that didn't become entrepreneurs last period, right? And that's just a univariate density that I'm going to call SR, right? So that's the state. And what does the planner do? Well, the planner has to decide who to assign to which Q every period, right? In order to maximize today's surplus, right? Plus the continuation value of now tomorrow's distribution of matches and singles. Okay. Now, at each point, so think of a fixed Q, right? The planner potentially has to pay a cost to form new matches, right? So if you think of the conditional density Q, or A given Q, if you form additional matches, right? So if M, that's the density of matches compared to the density of the state, then you're going to have to pay that resource cost mu for every single one of those matches. So it's potentially costly to form new matches, okay? So what that means is sometimes the planner may decide to not break apart matches, even though there has been a change in beliefs between yesterday and today. In fact, that's always the case, right? Your beliefs always evolve, okay? But because of this cost here, the planner may decide to keep some matches intact, break up others, and then whenever he can, he will sort, again, between productivities and beliefs within each cohort, right?
There is never all of them are matched.
No. So the market is short on the productivity side, right? So there's going to be a hazard rate into being an entrepreneur or manager, right? And so there's going to be entry and exit as well, in addition to churning within, right? So the question is, though, what is H prime and what is S prime? Well, H prime is effectively you take the matches, right? And then everyone gets a new signal, right? And then we sort of integrate out all the uncertainty and we know what the distribution of matches and updated beliefs is tomorrow, right? And the same is true for singles, but that's just a univariate distribution. That's a little easier to do. The key is that we can integrate out all the uncertainty, so it doesn't matter how you got to be a type 19 today. You may have been a type 24 yesterday and downgraded, or a type 10 and upgraded, but it doesn't really matter. All I need to know is how many type 17s do I have today, right? And that's what the law of motion will take care of. And then of course it has to be feasible, right? So sorry, just real quick. So the marginal density of M, right, the matches over Q has to be equal to you're integrating out the A's, so that's going to be equal to the available distribution of U's.
So I think about the real life. Older worker or entrepreneur is more likely to become entrepreneur CEOs because maybe have higher human capital or more experience and so on. So here, potentially could be like two guys have exactly the same expected productivity just because he's older, so opportunity is low, is smaller. So the planner want to give this older guy the job because productivity is small. Is it comfortable to see?
So say it one more time. So he wants to give the job to the older guy. Why?
Because his variance is smaller.
He observed it for a longer period.
So the variance matters here, right? Because it affects the surplus, right? So suppose you have you and me, you're a low variance type, I'm a high variance type, right? Because we have a different age. Then for us to be matched to the same productivity, right, we can't have the same belief about our abilities, right? That's kind of how this works here, because now the variance is going to interact with the curvature, right? So if we're matched to this, if the planner decides to match us to the same technology, then we must have different beliefs if we have different ages.
But it's an alternative saying this is suppose the planner want to give a job to a guy, he would prefer to give a guy with a lower opportunity. Is that true or not?
It depends. So you'll see. It depends on exactly what X exactly is, right?
It's not necessarily.
So the question is, does the planner like uncertainty or does he not like uncertainty, right? And the question is like, well, I haven't told you enough about X. Sometimes, depending on how you write down X, you actually high variance is maybe not a bad thing, right?
Just because it's a switching cost you have there.
Yeah, the switching cost comes in multiple ways, right? So the switching cost means if you have an older guy, right, you also know that you're much more likely to have to replace him sooner, right? So you're going to have to incur the switching cost again more quickly, right? For a young guy, you also incur switching costs because they're pretty uncertain types, right? So you're going to have to be indifferent between all these dimensions of how you assign individuals to the productivities, and all these margins are going to matter, right? And we're only going to look, so this being said, we're only going to look at the stationary solution to this model. The transition dynamics are very, very difficult to write down here. So the simple case is, of course, when there are no matching costs, then kind of this whole business of should I preserve a match or not becomes moot, because every time the planner it says like I can reassign everyone at no cost, so I'm just going to do it anyway. Okay. And so what's going to happen is, rather than having to solve this Bellman equation, effectively the planner just said like I just need to know how much surplus you're producing today. And for a given Q, I just have to be indifferent across agents of different ages and abilities, right? And then you work your way through the distribution and you have perfect sorting within each cohort. But that's really all there is to it. You don't have to solve the Bellman equation at all. And you just have to check that the assignment is feasible, right? So there's sorting, and then there is the capacity constraint, and that's it, right? So that's very easy to solve. When you have costly matching, then it becomes a little bit more complicated. So suppose you have a productivity Q, and yesterday you matched someone to this productivity with ability A hat, okay? But there's a new signal, and now you wake up the next day, and in fact the belief about my type has changed, right? So I'm going to call this A hat inverse, whatever this thing is called. Okay, so now the planner has decided, like, should I break up this match or should I keep it? Okay, and the question here is, well, two things I need to check. One is I know that I'm going to in a stationary equilibrium, I know exactly who should be matched with Q, right, for it to be optimal. So I have to check how much do I gain from replacing me with the optimal type, okay? But then I also have to check what's my value in my new match when I'm being separated, right? So that's going to be this one here. But for that to happen, the planner has to break up another match, right, to make room for me, right? So then he has to check how much is the gain from breaking up an existing match to the one that I'm going to be assigned to. And so this indifference condition is going to trace out kind of an inaction band, right, for each productivity and age within which you decide to preserve the matches, because the gains from reassigning are just too small to justify the cost of forming new matches. Okay. Now here there's like this index function with Qs, which has to do with the fact that I can always break up a match and so suppose I'm a particularly lousy type, okay? Then the planner might say, like, I'm not going to assign you to anyone else, right? You're just going to take the outside option, right? But in that case, you only have to replace one match, right? So I'm going out, I take the outside option, it doesn't cost the planner or anything, so all he has to do is bring in one new person and form one new match, right? There's no swapping. And so in the decision problem, the planner checks whether he wants to drop you altogether or if he wants to reassign you to a different productivity in the economy. Okay. So just to illustrate the point, let me just set up some functional forms. It's mostly just to build some intuition. We're going to assume that the function here is Cobb-Douglas, and that effectively the contribution of the manager is going to be like as if the types were log normally distributed, right? So it's exp of A. There's going to be 3 cohorts. There's a relatively small measure of firms, right? So only kind of the top tail of the distribution will even be assigned to a project here. And this is the precision of the true types, and this is the precision of the signals. Doesn't really matter what these numbers are. It's just kind of to build some intuition. And then the cost, I'm going to express relative to the expected surplus of the marginal match in the undistorted or in the frictionless economy, just to put some scale, into all of this. And so in this plot here, what you see is, so think about the following. Planner decides to assign someone to a productivity, right? what's going to happen is, going forward, some of these locations or productivities are not going to be available for a new match tomorrow, right? Because the planner decides not to break it up, okay? And potentially the rate at which you break up, even for a given match, is going to be different across ages, right? So young entrepreneurs might be separated at different rates from old entrepreneurs. And so what's going to happen is this sort of a congestion effect that occurs across the size distribution, and what I'm plotting here is which fraction of each productivity, right, is actually available to be assigned to a new manager each period. Okay. And generally what happens, because the fixed cost is a dead weight fixed cost, right? It matters a lot more for low productivity matches than high productivity matches. So effectively here, the fixed cost for really high productivity firms barely matters, right? So pretty much all these firms are going to be available to be reassigned. But smaller firms, you might preserve them, right? And so the higher this fixed cost is, the lower the fraction of the matches that's going to be available for a new assignment each period. Okay. Now, why is it not monotone? Well, it's because in the lower part of the distribution, you have a lot of people that just exit every period, right? And that's cheaper, right? Because you only have to form one match, so you're much more willing to break up these smaller matches with marginal types. And so that's why you get this non-monotonicity result here. So now we can also kind of look at what the assignment looks like. Sorry, this is a little smaller than I wanted it to be. Compared to the frictionless case, right? So blue is the frictionless assignment where this is the label of the firm, right? We're just indexing firms on 0, 1. And what you see is the friction means that you kind of have to be more competent to be even in the market, right? Part of that is because there's fewer, in the stationary equilibrium, there's fewer projects to be matched with. So you're just moving further out into the tails of the ability distribution when you match. And this is a little bit subtle, but if I increase the cost, so this is 30% of the marginal surplus, 60, 90, what's going to happen here is you see that not all age cohort are affected in the same way. So the age distribution is going to be shifting with these costs, okay? So for instance here, these are the guys that are one period away from retirement, right? They're really affected by the fixed cost because if you assign these guys to a project, you know for sure that tomorrow you have to assign another one, right? So you're going to have to incur the cost again. Here, on the other hand, with some probability, you can actually preserve the match and save yourself the cost of forming a new match, right? And there's going to be an age profile for each ability and productivity pair. We can now look at the value, right, of a firm, firm by firm, as a function of how high these costs are, right? So the blue line here tells you what the present discounted value is in the stationary equilibrium of a firm labeled 0 all the way to 1, right? Once we have these costs, the value of the match starts to drop, right? But it starts to drop much more for smaller firms than larger firms. I mean, the fixed cost of forming a match up here is effectively trivial. I mean, it just doesn't matter very much, right? So you're going to break up most of the matches anyway. So out here, the economy looks like the frictionless economy almost, right? But down here, this is in logs. So these values drop by a lot, even for relatively small, well, quote-unquote small match formation costs. Okay.
At least in the US data, I mean, the larger firms have lower turnover.
Right. So here is so there's a little bit of a tension. In the model and in the data as well, you have that effect, right? And then the other effect is that out here, the age distribution is very heavily skewed towards older guys, and they have low turnover in the model and in the data, right? So there is something happening with age distribution that is distinct from... Exactly. Yeah, exactly. Right. This being said, this picture tells me that the way we model the cost is not quite right, because we still have way too much churning out here, right? And that's not consistent with the data. Even the age profile helps us, but it's not going anywhere near where we need to, right? So the way to think about this is that the cost of forming a new match is proportional to, to the output of a 1 period surplus or something like that, right? Where you just want to scale it up. It turns out it's actually fairly straightforward to do. It's just that these are very new results. So on Monday or Tuesday, we thought actually we should try this with proportional costs. Right? I don't think it's much harder, but you're exactly right. There's just too much churning in the model. So I'm going to show you, so the problem with having these matching costs is that solving the model is much, much harder. I mean, I did not appreciate how much harder it was going to be. So in the data we look at 30 cohorts at a time, and we just cannot solve yet the model with fixed costs and 30 cohorts. It's just computationally too intensive. So just as a quick, I think I have probably what, 5 minutes?
Yeah.
5 minutes?
6.
5 or 6, okay. So what I'm going to do now is I'm going to say, let's just take the version of the model that we know how to solve, and let's parameterize it to the best of our abilities, and then see in which dimension the model does well. And there's going to be good news, which means that our conclusion is this is the model that actually can speak to these facts, with one exception, and that's going to be the reason why matching costs are going to play a major role. Okay. So let me just go walk you through this exercise and tell you a little bit about the data. So effectively what we're doing is we merge 3 data sets, and we can do this because in Denmark essentially you can match based on effectively the social security number, right? So we can take data from the register data, which covers employers and employees. We can match that to some accounting data. It's not complete, but it's pretty good coverage. And then we can match a third data set that tells us about the officers of all the limited stock companies in Denmark. So we can figure out who's a CEO, who's sitting on the board, and so on and so forth. So we have pretty good, it's not perfect, but we have pretty good coverage. So we get about 94% of all firms have a well-identified CEO. Sometimes 2, that's a bit of a problem. And we're gonna drop some observations. I'll tell you in a second. So we have an unbalanced panel. So remember, it's 10 years. There's entry and exit in terms of firms. On average, we have about 5,700 firms per year. The sample isn't fully representative. We decided to drop all the very small firms, not because we really want to, but there just is issues with small firms in the data set. We drop firms that have only part-time CEOs because we don't really want to think about someone who's splitting time between being a CEO and doing something else, or potentially being the CEO in multiple firms at the same time. It just doesn't map into our model very well. This excludes very small firms for the most part. There are some firms that don't have accounting data, so we don't know much about the size of the firm, and that's going to be a problem in terms of generating the size distribution. And then we're going to look at CEOs between the age of 25 to 54. That's kind of the age range. Okay. When we put some parameters on there, we need to pick parameters that govern the curvature on X, the precision of the noise, the productivity shock, how many projects we have relative to the size of the universe of individuals. We have to pin down the distribution of the productivities, and we have to pin down the fixed cost, which for now I'm going to set to 0. And for the parameterization, I'm going to assume that X is a CES function, right? So I'm going to have this parameter sigma that allows me to govern the curvature very easily, right? So high values of sigma means it's a linear, or towards linear, low goes towards Leontief here. And like before, we're going to assume that effectively the managers are making log normal contributions to the match surplus, right? That's something that's pretty standard. We can do some normalizations. We're going to require that these weights add up to 1. That's the model is scale invariant, so it doesn't really matter how we do that. And then we can normalize the distribution of talent to be a standard distribution. Okay. And then we can take the parameters and map them to moments in the data. So So this psi here is the tail shape of the productivity distribution. That matches almost 1-for-1 into the observed tail index of the productivity distribution in the firm size distribution in the model. N is easy to pin down, and then the remaining parameters are sort of jointly determined. It's not so clear that one particular moment informs one particular parameter. Okay. So what does that look like? We're going to try to, did I say this? Oh, yeah, we're going to try to get the age profile right, and then we're going to try to get this the distribution of managers across the firm size distribution that tilts from young ones to old ones like this. So we're going to try to get this tilt right as well, right? And so this is what it looks like. So we're targeting this and this, okay? We're targeting and we're hitting it by construction. And what we don't get is this sort of slight decay in the fraction of CEOs in the data. That's a pretty common feature, and the model is never going to be able to sort of address that. So it's just something that we can't quite fix. And then the second one is that we're targeting this. We just gave up on exactly matching it, but this is where we're going. We can go there. And so there's 3 parameters, and what we roughly get right is that this tilting from essentially skew to one side to the other side is occurring in the model as well as in the data, right? So young guys are heavily concentrated in small firms, and then over time this sort of shifts where now the profile is a bit more tilted towards larger firms for the older CEOs. Okay. Here's what we don't get at all, which is the churning, meaning the transitions from one firm to another, right? We do get the inverted U-shaped, okay, that's fine, but the magnitudes are way, way off, right? In fact, we have to have 2 different scales. In the model, you get really high rates of churning, right? As opposed to in the model where the rate of turnover is much, much lower, right? So average tenure is somewhere on the order of like 7 years or something like that. We don't get anywhere near that in the model, and that's the reason why we think some way of dampening the churning is required in order for the model to fit the data better, right?
But mu positive is clearly going to go in that direction.
It is going in that direction, right? It's the way we have it now is it's going in a direction for this part of the size distribution, right? We're gonna struggle here.
That's why you said you want some proportional.
We want some proportional cost, right?
Yeah.
Okay, and then it's a quantitative question whether or not we're going to get the churn exactly right. Okay. So I'm out of time and I'm out of slides, I think. Let's see. Yes. So like I said, we're still working on parameterizing the model with sort of the empirically relevant number of cohorts. That's just computationally a bit of a challenge. And then the decentralization is actually going to be kind of helping us with pinning down how much curvature there is, which is in and of itself an interesting question because it allows you to make statements about aggregate TFP, how sensitive the economy is to mismatch in terms of measured TFP, which is sort of a literature that has emerged over the last couple of years, which I've written as well. Let me stop here. I'm happy to take questions over the break.